what is the unit circle? The unit circle is a circle with a radius of 1 unit. Let me try to draw one. So if I have a big circle here, the key is that it's got a radius of 1. So I'm going to put a coordinate axis system on here. We have our usual x and y. And if it has a radius of 1, I can actually label these points on the corners. So r is 1 here, right? And so if r is 1 for the circle, I'll make that clear by writing it down here. We've got a unit circle, and the implications here really are that r is 1. Okay, so this point would have in coordinates, well, x will be 1 and y is 0. So we can label it, say, 1 comma 0. Similarly, if I look at this point up here, let's fix this a little bit. Not the best circle artist. Drawing a circle is very challenging. And this is going to have coordinates of x would be 0 and y is 1. And again, I know that because r has to be 1, so the length of that segment must be 1, right? I've got this radius, and it's always sweeping out, and well, r is 1. Similarly here, radius of 1 would make this have coordinates x is actually negative 1, because r is all in the x direction, and y would be 0. And similarly at the bottom, we're going to have x is 0 and y is negative 1. Okay, so that's, fine and dandy. But what about the points in the middle? Like how do we figure these out? Like, let's say I have a point over here. Now, if I don't tell you anything else about it, you have no idea of knowing what those coordinates are. So I got to give you something. What if I say, hey, I went up by 30 degrees. Okay, so this arc here is 30 degrees. Can we get the coordinates of that point? Well, it turns out that you can if you know your 30-60 triangle. So this is presupposing that you actually know that triangle. So that triangle, put it over here. If we have a right triangle, and this is 30 degrees, and then this is 60 degrees, the idea is that you should maybe know that. And the ratios, it's hard to draw these exact, but opposite 30 is 1, the hypotenuse then is 2, and opposite 60 is the square root of 3. So all 30, 60, 90 triangles are in that ratio, okay? So if I come over here, I can actually draw a right triangle within the unit circle. I just go up and then straight down, okay? Now, the unit circle, however, has r as 1. So here the hypotenuse has a length of 1. So it's going to have the same proportions as over here, but it's scaled by, you can see, going from the 2 to the 1, 1/2. So the other sides then, the opposite, the 30, the 1 is going to be a 1/2 here. And then it's not opposite, it's opposite the 60, they call it adjacent to the 30, is going to be the square root of 3 over 2 because it's half. Now the 30 degrees, which I put on the outside, is also here on the inside. Because this is kind of cool. The way that angles work is that it spreads out and it's always, the arc is always 30 degrees no matter how far you go. Okay, it's kind of cool. Okay, so what that does is it tells us the x and y coordinates. So the x here is going to be square root of 3 over 2. And the y is going to be 1/2. Because coordinates are always x comma y. Now, have we really gained anything from this? It seems like, whoa, like this is just like a bunch of extra stuff. But bear with me, okay? So how do we like look at this? Well, consider the following. Do you know the Sohcahtoa thing? This is like a mnemonic device to remember Sohcahtoa, how to connect the sine, the cosine, and the tangent with the opposite, the hypotenuse, and the adjacent sides. So it's like how to memorize, like, sine, cosine, and tangent are ratios of right triangles. And so here we say the sine, it's S-I-N-E, just use 3 letters for sine, cosine, and tangent, is the opposite over the hypotenuse. Okay? And similarly, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So if I look at the sine of 30 degrees, let's look at it in 2 different ways. I can consider this triangle up here, I've got the opposite over the hypotenuse as 1/2. Okay, but now look at it over here. Okay, what is the sine of 30? Well, it's got to be the same thing, but look at what happens. It's 1/2 over 1. Okay, well, clearly that gives us 1/2. How is that better? I mean, here we get 1/2. Well, consider this. If you're taking the sine of any angle theta, okay, here we've got sine defined as opposite over hypotenuse. The sine of that angle, and I'll put in the theta here, theta is an arbitrary angle, is still opposite over hypotenuse. However, in the unit circle, the hypotenuse has a length of 1. Therefore, the sine can be redefined as the opposite. Oops, I wanted to put the 1 there, not just write the same thing twice. And it's just the opposite. So we have an evolution in the definition of sine. And furthermore, the opposite has a clear meaning here. If you look at that, that's not just like some side, that is the y value. So this is actually the y value of the unit circle, okay? By a similar argument, if you look at the cosine, let's just do it. The cosine of theta is adjacent over hypotenuse, but the hypotenuse is 1, so it's just the adjacent, and that is, I'll put over 1, and that is the x value. Because if you look here, let's actually do it. So the cosine of 30, what I'm trying to tell you is that you can just look at the x value, it's root 3 over 2. And you get the same thing here, adjacent over the hypotenuse. So this does have some major advantages, okay? And I'm going to give you some of them now, okay? Let's just consider, some other sine values here, okay? What if I ask you to tell me what is the sine of 90 degrees? Well, you can't actually do this from a right triangle because the sine is not this one. Okay, it can't be the one in the corner because, well, first of all, it's this angle, okay? It's talking about this angle. So these angles can get bigger and bigger and bigger. You get like 89 degrees even. They'll converge way up there, but you'll never actually get 90 in a right triangle because you can't have 290 degrees because you got to have a third side to a triangle. But you can actually get it from the unit circle because it's simply the y value. And so what you find, okay, if you go up here, see theta, your angle is this arc. Okay, so if you go all the way up to the top, try to draw it for you, that top is going to have a theta of 90 degrees. Okay, 90 degrees. And the 90 there, it has like a, it has the coordinates, so we can see that sine, okay, is the y value, okay, it's right down here. And so what that means is you can simply use the unit circle, x is 0, y is 1, to figure out that the sine of 90 is 1. Similarly, if you start at 0, it's the sine of 0. Well, y there is 0, okay? You can get them all like this, all the corners, nice and easy. But sine of 180, sometimes don't put the parentheses in, we know what I'm talking about here. Back down to 0, because it's just the y value. What's the sine of 270? You're just going around, it's 270 degrees. It's -1 because that's the y value. So the unit circle allows you to clearly get all of these different points, but there's more. Okay, so I got a lot of stuff up here. I'm going to do a little pause, get a little better organized for you, and then move on.